This brings me to a special type of diffusion, which is facilitated diffusion. Now, facilitated diffusion is when the molecules still have a net movement from high to low concentration, but they may be too large or carry a charge which prevents them from directly crossing the cell membrane. So, what these smart large molecules do is that they use some help from a protein. They make use of transport proteins embedded in cell membranes to pass through it. But did you notice how it's still called facilitated diffusion? Well, that's because it's still a kind of passive transport with movement down the concentration gradient without the use of energy. It's noteworthy to remember that the rate of facilitated diffusion is mostly higher than simple diffusion. Alright, now, let's discuss osmosis. This too is a kind of passive transport during which the water, specifically water, moves from areas where solutes are less in concentration to areas where they are in a higher concentration through a semi-permeable membrane. This is best understood if we understand what tonicity means. Tonicity basically means relative concentration of solutes in the solutions being compared. So, a solution can have three kinds of tonicities. They can either be hypertonic, or isotonic, or hypotonic solutions. Hypertonic solutions means a higher solute concentration in solution than in the cell. Isotonic solution means equal amounts of solute in both the cell and the solution. Lastly, hypotonic solution means that there is a lower solute concentration in solution than in the cell. See how here we've got two types of solutions separated by a semi-permeable membrane. And here A is the concentrated solution and this one B is dilute. Notice how most of the water molecules will move from the dilute to the concentrated solution, that is, from B to A, just as we learned today. I'll leave you with a little tip. Most people get confused between hypertonic and hypotonic, but remember, they are very different. Just visualize some hyper kids who want to go play outside when you think of hypertonic. So, if a cell is put into a hypertonic solution, that water will leave the cell. Wasn't that helpful now?